a compound plus another compound, both ionic, is going to be a double replacement reaction. Now that we know it's a double replacement reaction, we're going to take first and last, and we're going to put them together. Keeping in mind that calcium has a charge of +2 and phosphate has a charge of -3. So now that I know the charges of my calcium, which is +2, and my phosphate, which is -3, when I put them together on the right side, it's going to go calcium and phosphate. We keep the 4 because that is part of phosphate's formula, PO4. Now I can balance the charges. This is a +2, this is a -3. So 2 times 3 is 6. We need a common factor of 6. So now I'm going to work vertically. 2 times 3 equals an overall +6. 3 times 2 gives me an overall -6. And now my charges have been balanced. Plus, and now we're going to do third and second get together. And I'm going to go look up the charges of K and Cl. K has a charge of +1. Chloride has a charge of -1. So this is a -1. Potassium is a +1. So over here, we're going to put potassium and chloride. Do not carry over subscripts. So I do not bring the 3 over here, and I do not bring the 2 over here. We're going to just balance the charges, +1 and -1, and it turns out they cancel. So now that I have predicted my products and balanced their charges, I can balance the coefficients. 1 calcium, 3 calcium, we'll put a 3 here. 3 times 2 is 6 chlorine. So here I need 6 chlorine. We have 3 potassium, but over here we have 6 potassium. So 3 times what will give me 6? 3 times 2 will give me 6 potassium. And then finally, I want to balance phosphate or PO4 as a bundle. So here I'm going to treat these as a bundle. And I have 2 phosphates here and then 2 phosphates here. So the phosphates are actually balanced. So we have 3 calcium, 6 chloride, 2 times 3 is 6 potassium, 2 phosphates, 2 phosphates. Final answer is 3 calcium chlorides and 2 potassium phosphates yield calcium phosphate, 1 calcium phosphate, and 6 potassium chlorides.